So this is the small signal incremental picture, and we have to make sure that C1, C2 and C3 are shorts at the signal frequencies. Okay, how do we do it? As before, we do it one by one. We don't try to evaluate the transfer function between Vi and Vo, including all three capacitors, and it's not worthwhile doing because what we want is a constraint. We are going to be making the capacitors much larger than this constraint. Okay, so now while evaluating the constraint for C1, we assume that C2 and C3 are short circuits, okay, and so on. And our usual method is to find the resistance that appears across the capacitor and make sure that the capacitive reactance is much smaller than that resistance, okay. And we deactivate the input. We set Vi equal to 0. Okay, now C1, it's very easy. You have this loop. Okay, Vi is 0, so that means this is a short circuit. And what appears across C1 is Rs plus R1 parallel R2. So we want the reactance of the capacitor C1 to be much smaller than the resistance across it, which is Rs plus R1 parallel R2. And again, when we deactivate the input source, okay, this current source drops out, it turns out. Okay, you can work it out and see it will drop out. It will become an open circuit because it has 0 value. And if we look in this loop, this part is open circuited. We have C2 and Rd plus RL across it. So the reactance of C2, 1 over omega C2, must be much smaller than Rd plus RL. I have repeated this many times by now. This condition ensures that the output voltage here V0 would be the same as replacing C2 by a short circuit. Okay. As before, we can have another condition which is relevant when Rd is very large. We want the drain source voltage, the voltage at the drain here, to be nearly the same as the output voltage, and in that case the constraint is stronger, and 1 over omega C2 has to be much smaller than RL. Okay, and again, these are things that you have already seen before, so I am not going to spend much time on this. Now we still have this capacitor C3 that is left. Let's see how to calculate the constraint for that. Let's assume that C2 and C1 are actually shorts. That means that they have been chosen to be sufficiently large so that they are shorts at the signal frequency. And of course, while carrying out this exercise, Vi is set to 0, so this is also a short. Okay. Now where is C3 connected? C3 is connected between this point and ground, and the reactance of C3 must be much smaller than the resistance that appears because of the rest of the circuit between this point and ground. So what I have to do is to find the resistance between this point and ground, and that's quite easy. How do I do that? I apply a test voltage V test, evaluate the current that is flowing there, which I'll call I test, and V test by I test gives me the resistance. Now how much is that? First of all, the gate voltage is 0 because this is connected to 0. This is a short, and you just have Rs and R1 parallel R2. Okay, so if you look at this part of the circuit, we have Rs and R1 parallel R2, and the gate voltage is 0. Okay, so this is at 0 volts. There is no current flowing anywhere. Okay, so now VGS in this is VG minus VS, and VS is nothing but V test. The source voltage is V test. So VGS equals minus V test. It is 0 minus V test. And what is the current I test? That is equal to the negative of this current. This GM times VGS is flowing downwards. The I test is opposite to that. So I test is minus GM VGS, and VGS itself is minus V test, so we get GM times V test. Okay, and V test by I test is 1 by GM. Okay, so the resistance between these 2 points where the capacitor was connected is 1 by Gm, and the reactance of the capacitor C3 has to be much smaller than 1 by Gm. Okay. Remember, when we had this drain feedback structure, when the gate is connected to the drain, the small signal resistance of the equivalent 2-terminal element is 1 by Gm. Here we have a similar result. If you look into the source of a transistor, you will end up getting 1 by Gm. Okay. So please analyze this by yourselves and convince yourself that the resistance that appears between these 2 terminals because of this circuit is 1 by Gm. Okay. And that gives you the constraint for the capacitor C3. So this way we can find all the capacitor values and design our common source amplifier properly. Okay.